Hello everyone, my name is Emmanuel, and today I'll be demonstrating Newton's law of cooling. For my situation, Dave maintains a fish aquarium, regulating its water temperature with a heater. Before leaving for work one day at 7:30 a.m., Dave forgets to plug the heater back in after a water change. During his lunch break at noon, he realizes this and checks the water temp via an app on his phone. It's cooled from its initial temp of 26 degrees to 20 degrees Celsius. If the fish's lives are at risk when the water temp reaches 18 degrees Celsius, how much more time does Dave have if the room temp is set at 17 degrees Celsius? So we're given an initial temp of 26, a temperature after 4.5 hours of 20, and a surrounding temperature of 17 degrees. For the problem, given the following differential equation for Newton's law of cooling, determine how much longer it will take for the water temp to drop to this critical level of 18 degrees. So here's our differential equation, and let's go ahead and get started. So first thing we want to do is separate the variables by moving the temperature variables to the left side and the time variable to the right side. So dividing both sides by t minus ts will give us 1 over t minus ts dt equals negative k dt. So now we're ready to integrate. 1 over t minus ts is simply the natural log of t minus ts. And then on the right side, negative k gets pulled out since it's a constant. And the integral of dt is just t plus our constant. And the next step is to solve for the constant. So what we can do is use our initial temp, since time of t will end up equaling 0 and canceling out the k here. So natural log of 26 minus 17 equals negative k of 0 plus c. So 26 minus 17 is 9. So our constant is equal to natural log of 9. So we'll plug that back into our equation here for our next step. And the next step we want to do is solve for the function, the temperature function with respect to time. And so basically we want to isolate this or solve for temperature, and how we can do that is by exponentiating both sides of this equation. So when we do that, we can apply some properties of logs, such as e to the power of natural log e equals 1, since natural log has a base of e, and then e to the a plus b is the same as e to the a times e to the b. So we'll cancel this and rewrite the equation as t minus 17 equals e to the negative kt times e to the natural log 9. We already know this cancels out, and we can bring the 9 up to the front here. And then also, let's go ahead and add the 17 to the right side. So what we're left with is t equals 17 plus 9e to the negative kt. And t here is the same as temperature with respect to time. So that is our function. And for our next step, we're going to use that same function and now solve for k. So we can use the information that we have. Temperature at 4.5 hours equals 20 degrees, and we'll plug that into the equation here. So 20 equals 17 plus 9e to the negative 4.5k, because t is 4.5. So subtract 17 from both sides, and we'll get 3 equals 9e to the negative 4.5k. Divide both sides by 9. We get 3 over 9, which is 1 over 3rd, equals e to the negative 4.5k. So the next step is we want to bring this k out of the exponent. We can do that by taking the natural log of both sides. So natural log of 1/3 equals the natural log of e to the negative 4.5k. And we know from this property that we could bring the b down. So this ends up becoming negative 4.5k times the natural log of e. And we already know the natural log of e equals 1. So we can kind of just get rid of that and simplify that, since that equals 1. And so from here, we want to solve for k. So we'll just divide both sides by negative 4.5. So k equals the natural log of 1/3 over negative 4.5. And we'll use that in our next equation here, but instead of writing all of this, we'll just write it as k for now and then plug that into our calculator later on. So last step is to solve for t, and we can do that by plugging in our last piece of information here, which is the final temp that we want, which is 18. So the critical temp of 18 equals 17 plus 9e to the negative kt. We already know the k, but we're going to keep it as this to keep things a little bit cleaner. So subtract 17 from both sides. We'll have 1 equals 9e to the negative kt. Divide both sides by 9. We get 1/9 equals e to the negative kt. And again, to bring these variables down, we'll take the natural log of both sides. And using the properties of logs, we can bring that down here. And the natural log e is 1, so we'll just go ahead and simplify that. And we're solving for t, so we'll divide both sides by negative k. And we're left with t equals the natural log of 1/9 divided by negative k. And we know k is this. So we'll plug that into the calculator, which gives us 9 hours. So we want to know how much more time Dave has. So from noon, which is 4.5 hours later, we're just going to subtract 4.5 from 9, and that gives us 4.5 hours. So that's how much time he has left, which is the same as 4:30 p.m. So that's what time he needs to make it home to save the fish. And that's my problem. Thanks for watching.